All right, ladies and gentlemen, this is the Math Models Surveying Test Review Problem Video Solutions. There are only 2 problems, so we'll see how long this takes. The first problem is a chord problem, very interesting. And the second problem, I think even more interesting, and that is measuring the height of a distant object using close range measurements and angles. So that's cool. So we can actually measure the length to the base of and the height of a distant object just using angles and some short distance. That's really cool stuff. So we will get started with the chord question. All right. Let's see here. What are we given? We are given that r, that's the radius, is 5. Okay, so immediately we need to start labeling our graph. So here, the central point A to any point along the perimeter of a circle will be the radius. So that radius, okay, dash mark it in, that radius is 5. Okay, well, if any point to the central point is the radius, then that must mean this is also the radius. Okay, and then we're given this central angle, BAC, BAC. So this central angle is 40 degrees. Okay, so here is, maybe we should say step 1. We're going to show all of our work. Step 1, label the circle. Okay, I love writing down steps that we've already completed because we already did that. We labeled the circle. Great. Okay, now what should we do? Well, this should be step 2. Convert the central angle to radians. I'll put a link in the description to a video about radians if you find this interesting, because radians are very interesting, and I'm going to show you how to turn degrees into radians right now without a calculator, but definitely want to watch the video about radians to see where all that comes from. Okay, so now let's convert those to radians. So here's the key thing to remember. In a circle, how many degrees are there? Well, last time I checked, there were 360 degrees in a circle, and you have to know this. In that same circle, there are 2 pi radians. All right, so that's the relationship. So here's a direct variation problem for you. So the question is, how many radians are there in 40 degrees? That's a question. So, in algebra, we would replace that question mark with a variable like x, and then we would, I think the students now call this butterfly math. Never heard of it before, but it seems to work for the kids. They call this butterfly math, I guess because these shapes look like butterflies. I mean, I've always called it a proportion problem. So we've got 360 x equals 2 pi times 40. Okay, so what I'm going to basically do is divide both sides by 360. At this point, I find it is really necessary to prime factor everything. So we'll prime factor the 40. Of course, the 2 is already prime. Prime factor 40, 2 times 20, 2 times 10, and 2 times 5. Okay, so if I'm going to rewrite the numerator, well, I'll do that in a second. So I'm going to prime factor 360 now. 360, that would be 2 times 180. That's 2 times 90. 2 times 45. 3 times 15. And 3 times 5. Okay, so I'm just prime factoring. And the reason I'm going to rewrite this and show you what I'm doing. So I'm going to put all my factors up front. Start with that 2 in front of the 2 pi. I'm going to put that here, 2 times. Now, I'm going to begin to write the prime factors of 40. 2 times 2 times 2 times 5. So instead of 40, I'm going to write 2 times 2 times 2 times 5. Then the only thing left in the numerator is the pi, so just times pi. And I'm going to leave that in its exact form. Over prime factors of 360, 2 times 2 times 2 times 3 times 3 times 5. So 2 times 2 times 2 times 3 times 5. Okay, so let's see. 2 times 2 times 2 times 3 times 3 times 3 times 5. I left a 3 out. Alrighty, now that's 8 times 3, 24 times 3, 72 times 5. Yep, okay. So now let's cancel out what we can cancel out. Here, cancels, cancels, cancels. And the 5s cancel. So what I'm left with in a simplified solution is 2 times pi over 3 times 3, which is 9. 2 pi over 9. That is radians. 2 pi over 9 radians equals 40 degrees. All right? Okay, so this central angle is equal to, we'll just write it in here, 2 pi over 9 radians. You can abbreviate RAD, radians. All right. Okay, now what? Well, remember the process. We are going to bisect the central angle, just like that. And now I'm going to take half the angle, so 40 divided by 2. Well, if it's 40 divided by 2 is obviously 20, so what I can do is I'm going to find, I know that this divided by 2 is 20 degrees, so what I can do is I can take my radian measurement, 2 pi over 9, and I can multiply that times 1 over 2 to get half the angle. Okay, so once I do that, these 2's cancel out, leaving me pi over 9, which equals 20 degrees. So that's pi over 9 radians equals, this is radians, equals 20 degrees. All right, so why was that useful? Well, now I have formed a right angle. And we're now dealing with this smaller triangle, which I'm going to draw. I'm going to draw, let me shade in what I'm actually talking about here. I am talking about this smaller triangle right here. See that? That's what I'm going to draw down here, because we're going to be working with that triangle here. Let me draw that here. All right, and it's not to scale. Oops. Okay, it's not to scale, but this is, we're 20 degrees, or pi over 9 radians. Okay, and this is 90 degrees right here. What we want to know is, what is the height okay, would like to know the height. We already know this is the radius of the circle. Okay, so this is still equal to 5. So I want to know the height. Well, remember, so, which is sine equals opposite over hypotenuse. Okay, so what I have here is I have r times the sine of pi over 9 radians, okay, equals that height. Okay, that's how we're going to find it. So we're exploiting the properties of sine equals opposite over hypotenuse. All right, so if you're trying to find the opposite side, you end up with this. Maybe I should show this. I don't know. Let me just, so sine equals opposite over hypotenuse, and I want to solve for opposite, right? So what I'm going to do is multiply both sides by hypotenuse. So h times s equals O. Hypotenuse times sine of the angle equals the opposite side, okay? So that's what we're doing here because the hypotenuse is the radius. The hypotenuse, I can never spell it. Hypotenuse is the radius, and the radius is 5. So we'll put in 5 times sine of pi over 9 radians equals. I want to know what it is. Well, we have to use a calculator for this if we don't have a slide rule. And what we're going to hit here first, if we've cleared our memory, we'll hit mode, make sure this thing is in radian mode. Second quit. All right, so now I'll multiply 5 times sine, and here I'll put in second, and that way I get the pi symbol, divided by 9. So 5 times sine of pi over 9 equals 1.71, right? I'm going to leave this all like that, but 1.71 is it's enough. So I'm going to write that here, 1.71. Okay? Remember, that's an approximation. So here's the thing. What have I accomplished? I have found this distance. That's 1.71. Okay? Let me transfer that knowledge back up to the original picture. So this, let me do it in orange. Half the chord length, half this chord length is 1.71. Okay, so if half the chord length is 1.71, what is the full chord length? All right, that means that because these are symmetrical, right? I bisected the angle, creating two congruent triangles. So now this is also 1.71. So basically, I just need to multiply this times 2, and I'll get the full chord, 3.42. So together, the full chord length is 3.42. All right, that is my answer. So chord length, 3.42. All right, I'm very happy about that answer. Cool. And there it is. Now, look, if you're trying to figure out what work looks like, that is work. See that? That's the work needed to complete this problem. So if your paper just has that answer right there and nothing up here and nothing down here, that's just not going to earn the points because you're not demonstrating to me that you understand anything, right? So this is your brain poured out on a piece of paper, and that's why I want you to do it this way. Okay, on to number 2. Honestly, this is an infinitely more complex problem. So we'll take it easy. Okay, number 2. First, I should probably label. So here's step 1. Step 1, label. All right, let's label some stuff. What can I label? Well, I'm given angle DAC, and that's 34. So 34 degrees. And here is DBC, and that's 53 degrees. And then line segment AB is 7 feet. So here, line segment AB, this is 7 feet. All right, there we go. That's all we know. And we want to know that height, and then we want to know the full length. We want to know this full length right here, and we would like to know this height right here. I want to know those two things. But in order to do that, I've got to find out what this length is right there. All right, so a lot of things, a lot of moving parts. So DC is the height, and AC is the base. All right, so let's work with this. Now 2, okay, so we did that. Number 2, what should we do first? Well, let's write out what we know, right? Remember, this problem is all about tangents. It's all about tangents. So when we solve this problem, we need to review for a moment what tangent, the tangent function is. Remember, SOHCAHTOA, so tangent is opposite over adjacent. Think about that. The tangent of 34 degrees is opposite over adjacent. The tangent of 53 degrees is opposite over adjacent. So notice what was in common. This height is common to both this big triangle, let's say call it DAC, okay, that triangle DAC, and triangle DBC share this DC length in common. All right, so the height, think of this like a tree or something. The tree is the same height from both observation points. Okay, so that's what we're going to exploit. So we'll write down what we know. Write what we know. All right, and before we write what we know, we should label BC something. We're going to call, usually what people call this is, they call this distance right here. They call this distance right here L. Okay, they call this distance L. It's unknown. Okay, so this is this DC here, this unknown here. This is the height, and this is L. This is unknown. So let's label what we know from the graph. So write down what we know. Okay, what do we know? We know that the tangent of 34 degrees is equal to, and what is it equal to? Opposite over adjacent. So is equal to H, which we don't know, over adjacent, which would be 7 plus L. You see that whole distance would be 7 plus L. We don't know what L is, but we know that it's 7 plus L. 7 plus L. Okay, what else do I know? And I know that the tangent of 53 degrees equals opposite over adjacent. Now I'm here, okay? Forget about this triangle. I'm just working with this little one, DAC triangle. Okay, the tangent of 53 degrees is opposite, which is H, over adjacent, which is L. So tangent of 53 degrees equals H over L. Okay, so here's the key. This is the key. Okay, get h by itself for both equations. This is the key. If you can do that, get h by itself for both equations. So how am I going to do that for this one? Just think about it conceptually. I'm going to multiply both sides by 7 plus L. Okay, then I'll have h by itself. Over here, what am I going to do? I'm going to multiply both sides by L, then I'll have h by itself. So we'll do that here. Watch closely. So I'll perform that microsurgery right here. 7 plus L times tan of 34 degrees equals h over 7 plus L times 7 plus L. So there's the algebra, right? So these 7 plus L's cancel, leaving h by itself. So therefore, okay, these little dots mean therefore. You've got now distributive property. Tan of 34 gets distributed to the 7 and to the L. So you've got you have 7 times tan of 34 degrees plus L times tan of 34 degrees equals h. So that was, look, that was half of this. All right, now we're going to deal with this guy over here. So we've got h by itself. That's what we wanted. We wanted h to be by itself. We got that for this one. Good. Now I'll do the same thing here. It's going to be much simpler. Just multiply both sides by L. L times the tangent of 53 degrees equals h over L, and then L. So here these L's cancel out on the right, leaving me L times tan of 53 degrees equals h. Now here's the key thing. When I have two simultaneous equations that are equal to the same variable, I can drop that variable and set those equations or expressions equal to each other. So if 7 times tan 34 plus L times tan 34 equals h and L times tan 53 equals h, then that must mean, like it's a law of mathematics, since h equals h, that 7 tan 34 plus L tan 34 equals L tan 53. Okay? So that's what we're going to do now. We will set the two equations equal to each other. Okay, that really is what we're going to do now. So I've got 7 times tan of 34 degrees plus L times tan of 34 degrees equals L times tan of 53 degrees. Okay, now what? Well, I want to solve for L. That's what I want to do, solve for L. Well, how would I do that? Oh, okay. That is our next task. Okay, so if I want to get L by itself, I need to get both terms that have an L in it over on the same side. So let me just move this guy over, L tan 34 degrees minus L tan 34 degrees. Okay. Notice that they cancel right there. And I've got here 7 times tangent of 34 degrees equals L times tangent of 53 degrees minus L times tangent of 34 degrees. Okay, so now what I'm going to do is notice that I've got an L common to both terms right there, so I'm going to factor out the L. Okay, so over here on the left, I've still got 7 tan 34 degrees. But on the right, I'm going to factor out the L. So I've got here, I'm going to pull the L out. L, open paren, tan 53 degrees minus tan of 34 degrees, close parentheses. Okay, so now to get L by itself, I will divide both sides by tan 53 degrees minus tan of 34 degrees. Okay, tan 53 degrees minus tan of 34 degrees. And now on the right side, this whole term cancels out, leaving L by itself. Great, that's what I wanted. So basically I just need to do this computation right here. And the calculator can really be helpful. Notice that this time around we're using actual angles instead of radians. And we're just choosing that out of convenience. So we'll go to mode now and change from radians to degrees because we're using angle degrees instead of radians. Okay, so now I'm going to put this whole thing in there. If you want to use alpha y equals to make it actually look like the fraction, that's fine. So you got 7 tan 34 degrees over, now open parentheses, tan 53 minus, close parentheses, tan 34, close parentheses, and then final close parentheses. So that is a faithful representation of what we have right there. And let's see what the answer is. 7.235704103. I'm going to write the whole thing out. 7.235704103 equals L. Okay. Now let's make a note of that. This is important. Right? This is an important achievement to have found that. This is this right here, okay? So maybe I'll highlight it and put a box around it in green so we know that we found that green distance. No, right? So I've got L. Well, if I have L, ladies and gentlemen, then I have the base because 7 plus that is the total base. So look, just go back down here. If that's L and the whole base is 7 plus L, then that whole base AC, okay, that means that AC, that segment, that whole bottom segment, okay, equals 7 plus L, which equals, now that I have L, just add 7 to it, okay, 14.2357041. 14.2357041 feet. Okay, so that is the full base. And that was AC. That was something we needed to know. I guess we'll round 14.2 feet. Okay, so there we've achieved something. We found something that we had to find. 14.2 feet. Great. Now let's find the height, DC. All right, we're almost there. Look, we now have the base of this huge triangle, so we'll find the height. And here's how we're going to do that. We're going to use the sine function. SOHCAHTOA, sine, is, why did I say sine? We're going to use the tangent function. TOA, opposite over adjacent. OA, TOA. So tangent equals opposite over adjacent. And we'll just plug this in. Tangent of, what was the angle? 34 degrees equals opposite, which we don't know. That's what height is, H, over adjacent. So adjacent is 14.2357041. Okay, so if we want to know what height is, we're just going to multiply both sides, okay, by 14.57 or 14.2357041. 14.2357041. Right. So now that means that height is now by itself. So H, or the height, or DC, this is DC, equals 14.2357041 times tan of 34 degrees. Okay, so let's do that. Back to the calculator. We can just multiply that answer by the tangent of 34 degrees. Drum roll. Solved. 9.6021. We can just round to the nearest tenths place. 9.6. So this approximately equals 9.6 feet. Wow, what an exciting discovery. Okay, ladies and gentlemen. So we'll highlight this because it's super awesome. Or I'll put a, okay, that's what I wanted. And I'll highlight it in yellow inside because coloring is fun. Okay, so there we go. And back up to the top, height, well, that equals 9.6 feet, and we'll put that in here, 9.6 feet. Okay, well, we already put feet, whatever. So 14.2 and 9.6. Okay, total video time, 34 minutes. All right, so just to review, we did both of these problems. I think they were fun. And here is the full solution. All right. So watch this video again and again until you completely understand what's going on. I mean, here it is, guys. I mean, I'm showing you how to solve these problems. So now that this is publicly available, it'll be expected that you take advantage of the opportunity to learn this at your own pace, having your teacher right there walking you through the homework. So I hope this has been helpful. Thank you very much. Please make sure to like and subscribe.